So from the previous video we learnt how to find the acceleration by finding the gradient. Now I've got a problem here because I've got a curve. So the first part says use the graph to work out an estimate of the acceleration of the object at 2 seconds. That's really important. So I'm going to draw my line on at 2 seconds. Now what we want to do is we want to get a line, so a straight line, that is just touching, so it's a tangent to the curve at 2 seconds. So let's just plot on first where 2 seconds is. So seconds is along the x-axis, 2 seconds would be about here. So I want a line that's just touching that curve. Let's have a go. There we go. So it's about there. Now I don't want lines that look like this. They still go through that point. It needs to be matching the curve and just touching at that point. It's going to be about here. So then I'm going to draw on my, I need to go for my right angle triangle, nice points. Remember, we're trying to find gradient. So let's just pop our nice points on. I'm going to use the point, the blue point that we've already got. Another nice point. Yeah, I'm going to go across 2 and I'm going to go up to there. And again, like I said, there will be a bit of leeway here because everyone's line is going to be slightly different. So here I need to figure out, well, gradient is for 1 across, but I might not have that at the moment. So at the moment I've gone from here, which was 2 to 4, so that's 2 across that I've gone. And I've gone from 1 to, it's about 2.3, so between 1 and 2.3, so that's 1.3 altogether. So I've gone for 2 across, I've gone 1.3 up, so it's really important that you look at the axes when you're doing that. So gradient is always for 1 across, so I'm dividing by 2 on this side, I need to divide by 2 on this side, so I'm going to have 0.65, so the acceleration is about 0.65 and that's going to be meters per second squared. Okay, again, if you didn't know what units to put, you could have put the units into the calculation. So it was 2 seconds across, 1.3 meters per second up, and I need to divide by 2 seconds on each side. So I'd need to do meters per second divided by a second. So that's going to be meters per second squared. That's where the units come from. So that's part A. Part B, use the graph to work out an estimate of the acceleration at the object at 8 seconds. So let's do another line. I'm going to do this one in yellow. And 8 seconds, let's just mark on where 8 is. So that's about there. You can see my line's going to look slightly different now. So probably about there. I would say that's pretty bang on. And again, I need to do my, for 1 across, how many up? So let's have a look at B. Pick a nice point. I'm going to pick that nice point there because that's bang on a whole square. So I've gone how many across, how many up? So we've gone from 8 to 16. So that's 8 across. And we've gone from 3 to 4.5. Yep, 3 to 4.5, which is 1.5. So I want 1 across, because that's what gradient is, so I need to do 1.5 divided by 8. I can do that on my calculator. 1.5 divided by 8 is about 0.1875. Okay, so let's look at part C now. Use the graph to work out an estimate of the deceleration. That means I don't need to put a negative onto my answer because it's already decelerating, of the object at 16 seconds. So again, here's 16. Get my line. I'm going to do a line in green this time, I think. No, I don't think I've done that line very well. I think it's more like that one. You can see that it's just slightly, there we go. Okay, so I've got my line. Let's do my triangle. So I've got a nice point there. I've also got a nice point here. I'm going to pick that one. So we've got from 16 to 24. So that's 8 across. And we've got from 1.5 to 0.5. So that's 1 down. I'm going to keep the 1 at the moment. And don't forget it was 8 seconds across and -1 meters per second. I need to get it down to just 1. So I'm dividing by 8 seconds here. Dividing by 8 seconds here. So that's -1 over 8 meters per second squared. So -1/8 is actually -0.125 meters per second squared.